Right now, underneath the western suburbs of Naples, the floor of Europe's largest active caldera is rising again, and it just produced the strongest earthquake this region has recorded since continuous instrumental monitoring began. On the evening of July 31st, 2026, at 7:46 local time, the ground beneath Pozzuoli lurched with a magnitude 4.7 rupture, centered barely 3 kilometers deep, right beside the Solfatara crater, the same steaming, sulfur-soaked ground tourists have walked past for centuries without fully understanding what sits beneath their feet. Trains stopped running across the entire Naples rail network. The port of Pozzuoli shut down, cutting off ferry service to the islands of Procida and Ischia in the middle of peak summer tourist season. 21 people were injured, and by the following morning, this single earthquake had already broken a record that had only been set the year before. This is not a distant, hypothetical volcano story. This is happening right now under one of the most densely populated volcanic regions on the entire planet. And today, we are going to walk through exactly what changed, why scientists are using words like acceleration and critical transition, and what any of this actually means for the roughly 3 million people living in its shadow. Before we go further, if this is the kind of story that genuinely interests you, deep, honest breakdowns of what is actually happening beneath the surface of the planet, without the exaggeration that usually floods this topic online, subscribing means you will not miss the next update, and there absolutely will be one. If you have ever visited Naples, felt one of these tremors yourself, or simply find this kind of geology fascinating, drop a comment and let me know, because this community has some incredible perspectives to share. And if you find this useful, sharing it with someone who has family in that region or is planning a trip there could genuinely matter, because very few people outside Italy actually understand what has been quietly building under that city for the last 2 decades. Let us start with exactly what Campi Flegrei actually is, because most people picture a volcano as a single cone-shaped mountain, and this is nothing like that at all. Campi Flegrei, which translates roughly to the Phlegrean fields, or the burning fields, is a vast volcanic depression roughly 12 by 15 kilometers wide, sitting immediately to the west of Naples and stretching out beneath the coastal towns of Pozzuoli and Boccoli. It is not a mountain, it is a caldera, a sunken basin created by 2 catastrophic eruptions in the ancient past, one around 39,800 years ago and another around 15,000 years ago, each so violent that they collapsed the ground above the emptied magma chamber into the depression that exists today. Scattered across that depression are at least 24 separate craters and vents, remnants of thousands of years of smaller eruptions layered on top of each other. And unlike its far more famous neighbor, sitting just 20 kilometers away, Mount Vesuvius, which announces itself with an unmistakable silhouette on the skyline, Campi Flegrei hides in plain sight. Neighborhoods, apartment buildings, schools, and train stations sit directly on top of it, because for most of recorded history, that was simply considered normal. The last time Campi Flegrei actually erupted was in the year 1538, an event that in some ways demonstrates exactly how unpredictable and locally devastating even a modest eruption here can be. Over the course of about a week, an entirely new hill rose out of the ground, a cone scientists now call Monte Nuovo, stretching to roughly 438 feet tall, formed almost entirely from ash and volcanic debris ejected during those few days. It buried an existing village beneath it in the process. That eruption was small by Campi Flegrei's historical standards, a blip compared to the 2 massive caldera-forming events tens of thousands of years earlier, but it remains the most recent proof that this ground is capable of doing something sudden and physically transformative, not just something that shows up quietly on a seismograph. To put those 2 ancient caldera-forming eruptions into perspective, the more recent of them, roughly 15,000 years ago, is estimated to have ejected enough volcanic material to bury the surrounding landscape under meters of ash and pumice, across a huge stretch of what is now southern Italy, an eruption on a scale that dwarfs anything in written human history from that region. The older event, close to 40,000 years ago, ranks among the largest eruptions Europe has experienced in the last 100,000 years, releasing enough sulfur into the atmosphere that some researchers have linked its aftermath to a period of significant climate cooling across the northern hemisphere. Neither of those events has any modern equivalent brewing today according to current monitoring data, but they explain why Campi Flegrei carries the Supervolcano label in the first place, and why researchers take even modest signs of unrest here more seriously than they might at a smaller, less historically explosive volcanic system. Since 1538, Campi Flegrei has not erupted again, but it has never actually gone dormant either. What it does instead, almost continuously, is something called bradyseism, a term that comes from Greek roots meaning slow movement. Bradyseism is the process by which the ground surface across the caldera rises and falls over years or decades, driven by pressure, changes deep underground, as magmatic gases and hydrothermal fluids move through the rock and accumulate beneath a shallow sealed layer of crust. This is not a slow leak of lava working its way toward the surface. It is closer to a giant uneven pressure cooker, expanding and contracting the ground above it as heat and gas build up and occasionally find partial release. The most famous physical proof of this phenomenon anywhere on Earth stands right in Pozzuoli itself, at the ruins of what is known as the Temple of Serapis, actually the remains of a Roman marketplace. 3 surviving marble columns there are covered in distinct bands of tiny boreholes, made centuries ago by marine mollusks that only bore into stone sitting underwater. Those bands sit well above current sea level today, physical proof, carved directly into ancient marble, that this exact patch of ground has sunk below the waterline for centuries at a time and then risen back above it, an entire geological history recorded in a handful of Roman columns still standing in a public park. Modern, continuous scientific monitoring of this bradyseismic cycle really began after a crisis in the early 1970s. But the event that truly shaped how Italy prepares for this volcano came a decade later. Between 1982 and 1984, Pozzuoli experienced a dramatic bradyseismic crisis, with the ground rising nearly 180 centimeters over those 2 years alone. More than 16,000 earthquakes were recorded during that period, some strong enough to genuinely crack buildings, with the strongest reaching magnitude, 4. The Italian government made the drastic decision to permanently relocate around 36 to 40,000 residents out of the historic center of Pozzuoli, moving many of them to an entirely new town built on higher, more stable ground called Monteruscello. No eruption followed that crisis. The uplift eventually slowed, then reversed, and the ground spent the next 2 decades gradually subsiding again. But the disruption to tens of thousands of lives and the underlying uncertainty about whether an eruption was actually coming left a lasting mark on how seriously Italian civil protection authorities now treat every new phase of unrest at this volcano. That subsidence period ended in 2005, and what has followed since has been genuinely different from anything recorded in the previous cycles. The ground beneath Pozzuoli has been rising more or less continuously for over 20 years now, and unlike the sharp, dramatic spike and retreat of the 1980s crisis, this current phase has been slower, more sustained, and critically, still accelerating. By January of 2026, cumulative uplift at the monitoring station in the historic Rione Terra district of Pozzuoli had reached roughly 161.5 centimeters since 2005, more than 5 feet of ground rise, concentrated in one of the most densely built parts of the caldera. The current monthly uplift rate sits at approximately 10 millimeters, plus or minus a few millimeters, a pace that sounds small in isolation, but represents a sustained, compounding rise that has now gone on for 2 full decades without reversing. And seismicity has climbed right alongside it, though not in the simple, straight-line way you might expect. A study published earlier this year in the journal Communications, Earth, and Environment, led by researchers using a combined model of crustal stress and fault friction, found that the relationship between uplift and earthquake activity at Campi Flegrei has become distinctly nonlinear since 2005, meaning the rate of earthquakes has been accelerating faster than the uplift alone would predict. In February and March of this year, the caldera was producing somewhere between 47 and 70 recorded seismic events per week. Some individual 7-day stretches recorded well over 400 separate earthquakes, the overwhelming majority too small to be felt by anyone at the surface, but together representing a crust that is being stressed and fractured at a genuinely elevated rate compared to just a few years earlier. This is exactly the backdrop the July 31st earthquake landed on top of, and it is worth understanding why that specific event registered as such a significant milestone rather than just another data point in an already busy year. Italy's National Institute of Geophysics and Volcanology, known as INGV, confirmed the epicenter sat near the Solfatara crater at a depth of roughly 3 kilometers, shallow enough that nearly all of its energy reached the surface with minimal cushioning from the rock above. At least 10 aftershocks followed within hours, the largest reaching magnitude 3. 8 out in the Gulf of Pozzuoli, and residents described a swarm of more than 30 separate tremors rolling through the area over the course of that single evening. People on the islands of Procida and Ischia, sitting out in the bay, reported feeling the main shock sharply despite the distance. Dozens of families, too unsettled to stay inside, chose to sleep in their cars or in emergency gathering points set up by Italy's Civil Protection Department, rather than risk being indoors if a larger aftershock followed. The significance of magnitude 4, 7 becomes clearer once you understand the recent history it was measured against. In 2025 alone, the region had already experienced 2 separate magnitude 4. 6 earthquakes, one in March during an active seismic swarm, and another offshore on June 30th. Each of those had, at the time, been described as the strongest tremor to hit Campania in roughly 40 years. The July 31st event surpassed both of them, and civil protection officials went further, calling it the most powerful earthquake recorded in the area since continuous instrumental monitoring of this bradyseismic cycle began. In other words, this was not simply a repeat of an already familiar pattern. It was a new ceiling, set on top of a trend that had already been setting new ceilings on a roughly annual basis for the past few years. It helps here to actually explain what that magnitude number really represents, because a jump from 4, 6 to 4, 7 might sound almost meaningless on paper. The scale scientists use to measure earthquakes is logarithmic, which means each whole number increase represents roughly 10 times more ground movement and about 31 times more energy released. A jump of just 1/10 of a magnitude point, from 4, 6 to 4. 7 may look small, but the earthquakes that actually cause structural damage tend to cluster in exactly this narrow band, where even fractional increases in magnitude, combined with extremely shallow depth, translate directly into stronger shaking at street level. That is precisely why a rupture measuring under magnitude 5 was strong enough to injure 21 people, shut down an entire regional rail network, and force the evacuation of a working port, despite technically being a moderate earthquake by global standards. Depth mattered just as much as magnitude here. At only 3 kilometers down, almost all of that energy arrived at the surface essentially undiluted, hitting apartment buildings, train platforms, and port infrastructure that were never built with a rupture that shallow, that close, specifically in mind. To understand why Campi Flegrei keeps producing earthquakes like this without an actual eruption following, it helps to walk through the underlying mechanism the way scientists studying this system currently understand it. Beneath the caldera sits a genuinely complex magmatic system, with multiple reservoirs of molten and semi-molten rock distributed through the crust and upper mantle at varying depths. As heat and volcanic gases rise from that deep system, they interact with groundwater in the surrounding hydrothermal network. And this combined pressure is what physically pushes the ground upward over time. As that pressure builds beneath a sealed, brittle upper layer of rock, the crust itself accumulates stress, exactly the way a spring compresses when you apply steady force to it. Eventually, sections of that stressed crust fracture along existing fault lines to relieve the pressure, which is what produces an earthquake. Researchers studying the July 31st event specifically identified its focal mechanism as consistent with rupture along what is known as a ring fault, one of the deeper, more extensive fracture systems that essentially traces the buried outline of the ancient caldera itself, a structure capable of hosting larger, more continuous ruptures than the smaller, shallower faults that produce most of the caldera's day-to-day seismicity. This is also the exact mechanism behind what happened at Solfatara in 2017, a tragedy that still shapes how tourists are allowed to interact with this landscape today. Solfatara is a shallow crater filled with hissing fumaroles, bubbling mud pools, and visible sulfur deposits. Historically one of the most visited volcanic attractions in the entire region, precisely because it makes an otherwise invisible hazard. Suddenly, viscerally visible, in September of that year, a family of 3, including an 11-year-old boy, fell through a thin, deceptively solid-looking crust of ground into a pit filled with scalding volcanic gas and died from inhalation. The site has remained largely closed to the public ever since, a stark physical reminder that the danger at Campi Flegrei has never really been about lava at all. It has always been about a thin, unstable crust sitting on top of intense heat and pressure in places where people walk casually every single day. That distinction matters enormously when you're trying to actually understand what kind of hazard a place like this presents day to day, as opposed to the rare, headline-grabbing eruption scenario. Most years, most weeks even, the practical risk at Campi Flegrei has nothing to do with magma reaching the surface. It has to do with exactly the kind of event that just happened on July 31st, a shallow, moderate earthquake capable of injuring people, cracking older buildings, and disrupting transportation and utility infrastructure across a densely populated coastline. Emergency planners in the region have to prepare simultaneously for 2 very different timescales: the slow, multi-decade possibility of an actual eruption requiring the evacuation described earlier, and the much more immediate, recurring reality of moderate seismic swarms that can strike with only seconds of warning at best, given how shallow and close to the surface these ruptures tend to occur. Both hazards trace back to the same underlying bradyseismic process, but they demand very different kinds of preparedness, one built around long-range evacuation logistics, the other built around the kind of building codes, structural retrofitting, and public earthquake awareness that any seismically active region would need regardless of the volcano sitting underneath it. Now here's where the science moves from describing the present into projecting the future, and this is the part that has genuinely reshaped the conversation among researchers this year. In April 2026, a paper posted to the preprint server arXiv titled "Accelerating Unrest at Campi Flegrei Signals a Critical Transition" within the next decade, analyzed decades of combined seismic and ground deformation data and reached a conclusion that immediately drew international attention. Rather than describing the acceleration and uplift in earthquake activity as simple exponential growth, the researchers found that the pattern fit what mathematicians call a finite time singularity, a trend that does not just grow indefinitely but converges toward a specific window in time. Independent analyses looking separately at uplift rates, earthquake frequency, and carbon dioxide flux from the caldera's fumaroles all converged on roughly the same critical period, somewhere between 2030 and 2034, with projections suggesting total ground uplift could approach 4 meters by the early part of that decade if the current trend continues uninterrupted. It is genuinely important to understand what that projection does and does not actually claim, because this is exactly the point where online coverage of this story tends to go badly off the rails. A critical mechanical transition, in the language these researchers actually use, does not automatically mean an eruption. It means the system may be approaching a threshold where its physical behavior changes, potentially involving new ground fractures, a shift in how stress is distributed across the caldera, or a further increase in gas emissions from the fumarole fields, none of which guarantees magma will ever reach the surface. INGV itself, the agency actually responsible for monitoring this volcano hour by hour, currently classifies the system as being in a phase of accelerating unrest, not an imminent eruption scenario, and the alert level in Italy's official volcanic warning system remains at yellow, meaning attention, one full step below the orange level that would signal a genuinely elevated eruption probability, and 2 steps below red. But accelerating unrest, even without an eruption attached to it, is still a serious civil protection problem on its own, and Italian authorities have been treating it that way for several years now. More than 500,000 people currently live inside the designated red zone around Campi Flegrei, spread across 15 municipalities considered most directly at risk if the situation were ever to escalate toward an actual eruption. A further roughly 840,000 people live in the surrounding yellow zone, an area that would primarily face ashfall, rather than the more immediately lethal pyroclastic flows threatening the red zone closer to the caldera's center. Under Italy's national emergency plan, if monitoring data ever indicated a genuine transition toward the alarm level, meaning a high probability of eruption within a short window, the plan calls for the preventive evacuation of the entire red zone population within 72 hours, a logistical undertaking on a scale that has essentially no modern precedent anywhere in Europe. Regions and provinces across Italy have already been formally paired with specific municipalities inside the red zone, essentially pre-assigning where each evacuated community would be temporarily relocated if that order were ever given. The Italian government has been actively reinforcing this planning apparatus as the underlying unrest has intensified. Back in 2023, in response to a wave of seismic swarms that included several of the strongest earthquakes the region had experienced in 4 decades at that time, Italy allocated over 50 million euros toward a combination of structural inspections on buildings across the caldera, additional staffing and resources for local civil protection agencies, and a public awareness campaign specifically targeted at schools, aimed at making sure an entire generation growing up in the shadow of this volcano actually understands what bradyseism is and how to respond if a stronger earthquake strikes. Hospitals in the region have run evacuation drills specifically built around scenarios involving stronger seismic activity, testing how quickly emergency rooms could be cleared and how patients would be transferred if buildings sustained damage. A decree issued in October of 2023 introduced additional urgent measures specifically aimed at reducing seismic risk connected to the bradyseismic phenomenon, formal recognition, in the government's own language, that this was no longer a slow background process, but an active, evolving hazard requiring continuous new intervention. One detail actually works in the region's favor here, and it is worth being fair about it rather than presenting this story as unrelentingly bleak. Most buildings across the current Campi Flegrei red zone do not exceed 3 stories, and a significant share are built from reinforced concrete or masonry that has undergone seismic retrofitting. Since the 1980s, crisis reshaped how the Italian government thought about construction standards in this specific region. Italy's own civil protection authorities have noted that, so far, the current bradyseismic crisis has not produced significant structural damage on the scale seen during the 1982 to 1984 period, a difference they attribute both to those retrofitting efforts and to the somewhat different frequency and character of the current earthquake swarms compared to the earlier crisis. That does not mean the July 31st earthquake caused no damage at all. 21 people were injured and infrastructure across an entire transit network was disrupted. But it does mean the worst-case scenarios circulating in more sensationalized corners of the internet are not simply arriving on schedule the moment a new record magnitude gets set. It is worth walking through what an actual eruption at Campi Flegrei would realistically look like, because the range of possible outcomes here is genuinely wide, and lumping every scenario together under one dramatic label does nobody any favors. On the smaller end, Researchers point to something resembling the 1538 event, a localized eruption producing a new cinder cone or maar crater somewhere within the caldera, with ash fall affecting nearby neighborhoods and requiring evacuation of the immediate area. Serious and disruptive, but geographically contained. On the far more severe end of the spectrum sit eruptions on the scale of those two ancient caldera-forming events, essentially civilization altering in scope, but nothing in the current geochemical, seismic, or deformation data suggests the system is anywhere close to that kind of eruption. And researchers are explicit that the current unrest pattern, even in its accelerating form, most closely resembles the buildup towards smaller, localized activity, rather than a caldera-scale catastrophe. The entire purpose of Italy's tiered alert system, moving from green through yellow, orange, and finally red, is to give authorities a structured, evidence-based way to distinguish between these dramatically different scenarios as new data comes in, rather than reacting to every uptick in seismicity as though the worst-case outcome were automatically the most likely one. It is also worth directly addressing the comparison that inevitably comes up whenever a story like this breaks, the question of whether Campi Flegrei is somehow related to or as dangerous as other famous supervolcanoes people have heard of, most commonly Yellowstone in the United States. The two systems share a broad category. Both are large calderas capable of producing genuinely massive eruptions in the deep geological past. But their current behavior and their risk profile are shaped by almost entirely different factors. Yellowstone's hazard conversation centers overwhelmingly on shallow hydrothermal explosions, sudden localized steam blasts driven by near-surface groundwater, sitting in a park where several million tourists walk every single summer, with the actual magma system sitting many kilometers further down and showing no current signs of the kind of sustained, accelerating unrest Campi Flegrei has displayed for 2 decades running. Campi Flegrei's hazard, by contrast, centers on a genuinely accelerating, well-documented bradyseismic cycle sitting directly beneath a modern metropolitan population. Not a remote national park, but an urban and suburban landscape home to roughly 3 million people, once you include the broader Naples metropolitan area and its immediate neighbor, Vesuvius, sitting just 20 kilometers away and monitored by that very same observatory. Very few places on the planet combine this level of documented volcanic unrest with this much population density sitting essentially on top of it, which is exactly why Campi Flegrei draws such intense, sustained scientific attention, despite genuinely not being anywhere close to Yellowstone's raw physical scale. So where does all of this actually leave things right now, in the days and weeks following the July 31st earthquake? Seismic activity in the immediate aftermath has continued, with the Volcano Observatory Network recording smaller events on a near-daily basis in the surrounding area, most far too small to be felt, consistent with a fault system still working through the stress redistribution triggered by the main shock. Ground deformation monitoring continues around the clock through a dense network of GPS stations and satellite radar imaging, technology sensitive enough to detect uplift down to fractions of a centimeter across the entire caldera, giving scientists a genuinely detailed, continuously updated picture of exactly how the ground is moving week by week. Geochemical monitoring of the fumarole fields, tracking the mix and volume of gases like carbon dioxide and sulfur dioxide escaping from vents across the caldera, remains elevated compared to background levels recorded before 2005. Another data stream researchers are watching closely for any signal of a genuine shift in the underlying magmatic system, rather than a continuation of the existing hydrothermal-driven unrest. What makes this moment feel different from previous chapters in Campi Flegrei's long, restless history is not any single earthquake, even one as significant as the July 31st event. It is the combination of 3 things happening simultaneously for the first time in this particular configuration. 2 full decades of essentially uninterrupted uplift, something the caldera has not sustained continuously since long before modern monitoring began. A clearly documented published acceleration in both deformation and seismicity that multiple independent research teams using different methods and different data sets have now converged on describing, using very similar language, unrest that is not just continuing but genuinely speeding up. And a population living directly on top of it that has grown enormously since the last comparable crisis in the early 1980s, meaning the same physical process happening today carries a substantially larger human footprint than it did 4 decades ago. None of this means an eruption is coming next week, next month, or even within the time frame researchers have projected for a possible critical transition. Volcanic unrest, even genuinely accelerating unrest, has reversed itself before at this exact location, twice within living memory without ever crossing into eruption. But it does mean that treating each new record-breaking earthquake as an isolated, forgettable news item, the way so much coverage of individual tremors tends to, misses the actual story entirely. The real story is not any single magnitude number. It is the 20-year trend those numbers are part of, a trend that INGV, independent university researchers, and Italy's own civil protection authorities all currently describe using the same word, accelerating, and a trend that is now, for the first time, being modeled mathematically as converging toward a specific window rather than simply continuing indefinitely into an undefined future. There is also a practical, forward-looking piece of this story worth mentioning, because it is easy to focus entirely on hazard and lose sight of what is actually being built to manage it. Italy has spent the years since 2023 not just updating paperwork, but genuinely investing in the physical tools needed to respond faster if conditions do change. Additional seismic and deformation monitoring stations have been installed across the caldera in recent years, tightening the network of sensors, feeding real-time data back to INGV's operations center. Structural inspections of public buildings, schools, and hospitals across the red zone have continued on a rolling basis, identifying which structures would need reinforcement first if the government ever needed to accelerate its retrofitting timeline. And the transportation and logistics planning behind that 72-hour evacuation window has been tested and refined through periodic drills involving regional authorities, rail operators, and the municipalities designated to receive relocated residents. Precisely the kind of unglamorous, repetitive preparation that rarely makes headlines but genuinely determines how well a mass evacuation would actually unfold if it were ever ordered for real. For the roughly 500,000 people living inside that red zone right now, this is not an abstract academic debate playing out in scientific journals. It is the reality of watching your local rail network shut down, your neighbor's building get structurally inspected, and your city's emergency evacuation plan quietly get updated and rehearsed, year after year, while everyday life in one of Italy's most historically rich regions continues largely as normal in between each new tremor. That is genuinely the defining tension of living inside an actively monitored, actively accelerating caldera. The overwhelming majority of days pass without incident, ordinary commutes, ordinary tourism through ancient ruins that happen to sit on top of an active volcanic system. Ordinary life layered directly on top of a genuinely serious, closely tracked geological hazard. And then, every so often, the ground reminds everyone exactly what is sitting underneath it, as it did on the evening of July the 31st, injuring 21 people, halting an entire regional rail network, and quietly setting a new record that researchers had, in some sense, already been expecting to see broken. If you found this breakdown genuinely useful, subscribing helps this channel keep tracking Campi Flegrei and stories like it as new data actually comes in, rather than only revisiting the topic once headlines force the issue. Share this with anyone you know who has traveled to Naples, has family in the region, or is simply curious about how a modern, densely populated European city coexists day to day with an active supervolcano sitting directly beneath it. And drop a comment below because I genuinely want to know, had you heard about this earthquake before today? Or is this the first time you're learning just how far along this 20-year acceleration at Campi Flegrei has actually gotten? We will keep watching every new swarm, every fresh uplift measurement, and every update INGV releases as this story continues to develop. Because based on everything the data is currently showing, this is very clearly not finished. See you in the next one.